Good morning and welcome to Mathematics Telikilaas for grade 9. I am Daisy. Before we start today's lesson, make sure you have an exercise book, your pen, your pencil, eraser and of course a calculator. Today's topic would be the application of sine rule in calculating the missing angles in any triangle. By the end of today's lesson, the students would be able to identify sine rule in the sense how to use a sine rule, when to use a sine rule and where to use a sine rule. And secondly, they would be able to understand how to apply sine rule in calculating the missing angles of any triangle. Finally, they will also be able to understand the practical applications of sine rule in real life scenarios. Now, before we move into the topic, let's just do a quick recall on two basic concepts which you have learned in the previous classes. The first one being sine rule. Does anyone remember how we use sine rule in calculating the missing sides of any triangle? That's correct. We use sine rule when two angles and two sides are given, out of which one will be the unknown. Now let's check how do we use sine rule. If simple A represents the side opposite to the given angle capital A, and if simple B represents the side opposite to the given angle capital B, and simple C represents the side opposite to the angle capital C, then the sine rule would be A by sine A equals B by sine B equals C by sine C. Secondly, let's just recall the basic trigonometric ratios, namely sine, cos and tan, which is abbreviated as the Staccato rule. Now let me ask you a question. How many of you know how to calculate an unknown angle using a Staccato? So for that, let's just take a look at the given right triangle as shown with an unknown angle x. As you can see, two sides are given there, namely with 4 centimeter and 5 centimeter measures. Before we go on to this example, I have a question for you. Name the side opposite to the 90-degree angle in a right triangle. Let's see if you can remember it. I'll give you 1 second for that. Exactly, it would be the hypotenuse. So as you can see, the side that is opposite to the 90-degree angle would be the length 5 centimeter. And what about 4 centimeter? It would be nothing but the side which is opposite to the given unknown angle x. So now you have the hypotenuse which is 5 centimeter and now you have the opposite side which is 4 centimeter. So among the three ratios, which one you may use? You can use sine. So you may write it as sine x is equal to opposite by hypotenuse. Now substituting the two values there, you will be getting sine x is equal to 4 by 5. You may use the calculator and you will be getting the next step as sine x is equal to 0.8. Now let's just take a small pause over there. So now you have sine x is equal to 0.8. But the question under consideration is you need to find the size of angle x. Now how can you do that? You can find it using sine inverse. How many of you do remember how to use sine inverse? So for those who have forgotten how to use sine inverse, I can just give you a small explanation. The moment you get the answer 0.8, do not change the display. Keep the display as it is, then press the shift key, then the sign key, then open the bracket, press the answer key, close the bracket and then press the equal to sign, which ultimately will give you the final answer. So let's just take a look at what I explained using a calculator. As you can see, 4 divided by 5 equals 0.8. Keep it as it is on the display. Shift, then sign, open the bracket, answer, bracket close. You will get your final answer as 53.130102.354. You need not write the entire answer as the entire display as your final answer, but instead you can write it by rounding off to either 3 significant or 1 dp according to what is specified in the question. Now, what if the degree of accuracy is not mentioned in the question? Since we are finding angles, we can always write angles correct to 1 dp. And hence your final answer would be, rounding off, x is equal to 53.1 degree. Let's see how we can use sine rule in calculating the missing angles of any triangle. Just in the beginning of the lesson, we have seen what is a sine rule. A sine rule would be a by sine A equals b by sine B equals c by sine C, where simple A, simple B and simple C are the sides opposite to the respective angles capital A, capital B and capital C. Okay, I am going to do something very strange here. So, I am going to flip this formula, flipping in the sense I am going to write it upside down. So, in that case, what do I get? So, when I flip the formula, this is what I get. It would be sine A by A equals sine B by B equals sine C by C. Now, how can this flipping be done all of a sudden? Of course, we can do it. It's because the 3 ratios A by sine A, B by sine B and C by sine C are equal. So, even if we flip it, the ratios would still remain the same. Now, the question will be, why did I flip it? Now, since we are finding the unknown angle, it would be always better to write the sign of that unknown angle in the numerators. It's just to make your calculation pretty simple and easy. Now, in brief, to find the missing angles using a sine rule, you may use the formula sine A by A equals sine B by B equals sine C by C. However, it is not compulsory for you to just stick on to the flipped formula. You may use one of the 2 formulas. Either way, your answer would remain the same. Let's just focus now on 3 examples where we use sine rule to find the missing angles of any triangle. Example number 1. Use sine rule to calculate the size of the angle marked x and give your answer correct to 1 dp. As you can see, we have triangle PQR with measures PQ 9 centimeter, QR as 10 centimeter, angle P as 65 degree and angle R as the unknown angle x. So, let me ask you a question. Can we use sine rule here? Well, of course, 2 sides and 2 angles. Remember that always, 2 sides, 2 angles, you can use the sine rule. So, since we are going to start with the unknown angle x, let's see whether the opposite side of that angle is available. Yes, it is, which is 9 centimeter. So, what about the other angle? You have a 65 degree and then the opposite side of 65 degree, which is 10 centimeter, is also available. So, now let's start writing the steps using sine rule. Since the question asked is about the unknown value x, The side opposite to x is 9 centimeters. So we can start with writing sine x by 9 equals sine 65 by 10. Now what do we do in the next step? Obviously, you have to go for a cross multiplication. So cross multiplying, the next step would be 10 times sine x equals 9 times sine 65. Now how do we get the value for sine x only on the left side? So we can remove the 10 from there. How is that going to be possible? You can divide both the sides by 10 and ultimately the third step would come as sine x equals 9 times sine 65 by 10. Remember, your target is to get the size of the angle x, but on the right side you have 9 times sine 65 by 10. Here is where you may use the calculator to find the answer only for the right side by placing brackets in the numerator. So your answer would turn out to be sine x equals 0.8156770008. Remember that the question is only to find the size of x. So what can we do here? When we started in the beginning, we talked about using sine inverse. So here we have to use the sine inverse of that big value 0.8156770008. So the next step would be x is equal to sine inverse bracket answer bracket close. I hope you remember how we did this in the beginning. Press the shift key, then the sine key, open the bracket, press the answer key, close the bracket and press the equal to sign. Let's take a quick look at how we can do this using a calculator. 9 times sine 65, place it in a bracket, divide it by 10. So the answer would be 0.8156770008. Then you press the shift, then sign, open the bracket and you get your final answer as 54.654358037. Remember, do not write the entire display, but as the question suggests, you can round off your final answer to 1 dp and hence your final answer would turn out to be x is equal to 54.7 degree correct to 1 dp. So I'll just give you some time to go through this example. Let's take a look at the second example where we use sine rule to find the missing angles for the triangle. Use sine rule to find the size of the angle marked K and give your answer correct to 1 dp. As you can see, we have an upside down triangle ABC with the following measures. Now here you need to think, can we use sine rule here? Well, of course, 2 sides, 2 angles. You can definitely use the sine rule. Now the unknown angle to be found is K degree. Now what is the side opposite to K? You have 11.8. What is the side opposite to 37 degree? You have 9.2. So with this, let's start the first step to the answer. So since the question is asking about angle K, we can start writing as sine K by 11.8 equals sine 37 by 9.2. So what will be the next step? The next step would be cross multiplication. So when you cross multiply, you will get 9.2 times sine K equals 11.8 times sine 37. So you need to remove 9.2 from there. How can you do that? It is possible if you can divide both the sides by 9.2, which in turn will give you sine K equals 11.8 times sine 37 by 9.2. As we have seen in the previous example, what would be the next step? You can use the calculator, put brackets on the numerator and get the answer from the calculator for the right side. So, it would be sine k equals 0.771893181. As the question says, the target is to find the angle marked k. How is that possible? We can find it using the inverse. So, remember the display you have seen before. So, you will be getting sine k equals 0.771893181. So, your target is to find the size of angle k. How is that possible? You can find the sine inverse of the right side answer, which in turn would be k equals sine inverse bracket. Do not change the display, put the answer and bracket close, and ultimately your answer would be k equals 50.524. And as the question suggests, you need to give your answer correct to 1 dp. Rounding off, your final answer would be k equals 50.5 degree. Let's take a look at example 3. Use sine rule to calculate the size of the angle marked y. Give your answer correct to 3 significant figures. Now, let's take a look at the measures of the angle. Let's take a look at the measures of the triangle. AB equals 8 centimeter, angle A equals 80 degree, then side BC equals 15 centimeter. Now, since we have to find the angle marked y, unfortunately the side opposite to angle B, which is AC, is missing, but then the side opposite to angle C and the side opposite to angle A is available. So, it would be better, or we can say the only option here would be to calculate angle C first. So, how do we calculate angle C? Let's start writing the sine of C. So, sine C by 8 centimeter equals sine 80 by 15 centimeter. So, the next step would be obviously to cross multiply. So, cross multiplying, you will get 15 times sine C equals 8 times sine 80. So, the next step you can remove 15. So, divide both sides by 15. So, sine C equals 8 times sine 80 by 15, and you may use the calculator, divide it by 15 to get the answer as sine C equals 0.525230801. As the target is to get the size of angle C, you can take the sine inverse. So, the answer would be C equals 31.683, and you may write your answer to 3 significant figures. So, we have received the angle C as 31.7 degree correct to 1 dp. Now, you might be thinking, what if we find angle C? What is the use? Now, here in order to get the measure of y, you may use the angle sum property in a triangle. You know the sum of all the angles in a triangle is 180. Hence, the next step would be angle y equals 180 minus bracket 80 plus 31.7 bracket close, and your answer would be 68.3 degree correct to 1 dp. Practical applications of sine rule in real life scenarios. In olden days, trigonometry was extensively used in astronomy to calculate the angles of celestial spheres. Apart from that, it was used in map making and surveying as well. But now in the modern age, the applications of trigonometry has spread a lot into various fields such as engineering, architecture, satellite communications, criminology, oceanography, navigation, and so on. So let's just take a small look into one such life scenario from the field of navigation. The diagram shows the position of two ships, ship A and ship B, from port P. Ship A is at a distance of 87 km from port P and ship B is at a distance of 80 km from port B. If angle PAB equals 49 degree, this question has two subparts. The first subpart, A part, is find angle PBA. Now you have three positions here, ship A, ship B and port P. Connecting all the three, it forms a triangle. So as you can see, again we have two sides and two angles in which one unknown is there. Remember, two sides, two angles, you may use the sine rule. So let's start with finding the unknown x. So you may start writing as sine x by 87, which is the opposite side, equals sine 49 by 80. Again, as usual, we have to cross multiply. So you will be getting 80 times sine x equals 87 times sine 49. We need to remove 80 from here. So you need to divide both sides by 80, and the third step would be sine x equals 87 times sine 49 by 80. So what would be the next step? You can place brackets, use the calculator, and ultimately your final answer after taking the inverse everything would be x is equal to 55.2 degree correct to 1 dp. So the answer now for the unknown x would be 55.2 degree. Let's go for the B part of the question. Find the distance between the two ships A and B. Let's take a look at the previous measures. Now currently from the A part, you have received the size of angle B as 55.2 degree. So according to the question, you need to find the distance between the two ships A and B, which is nothing but you need to find the side AB. Now unfortunately, the angle opposite to x is missing. So your first priority here should be to calculate angle P. How is that possible? We can find it using the angle sum property in a triangle. Sum of angles in a triangle is 180, hence you may use angle P equals 180 minus bracket 49 plus 55.2 bracket close would give you 75.8 degree as the value of angle P. So now we have calculated the size of angle P as 75.8 degree. Now your target would be to find the side AB, which in turn will give us to apply sine rule in finding the missing side. So how are we going to write it? It would be x by sine 75.8 equals 80 by sine 49. Now it's not compulsory that you should take 49 degree and the side 80 kilometer. You may also take 55.2 degree and the side opposite as 87 kilometer as well. Still your final answer would remain the same. So the next step would be to cross multiply. So when we cross multiply, we will get x times sine 49 equals 80 times sine 75.8. How can we get the value of x alone? We need to remove sine 49 from there, which is possible only by dividing both sides by sine 49. So dividing both sides by sine 49, you will get x is equal to 80 times sine 75.8 by sine 49. You may use the calculator putting brackets in the numerator, and hence your final answer would turn out to be x is equal to 103 kilometer, correct to 3 significant figures. Here is an exercise for you to practice sine rule to find the size of the missing angles. You may take a photo or screenshot of the exercise and practice and get the help of your teachers to find the answers as well. The solutions to the exercise are as follows. Do cross-check your answers and do the corrections as well. With this, we have come to an end of today's class, and before we conclude, let's just summarize what we have learned on sine rule. Sine rule is used for two purposes: to find the missing sides as well as to find the missing angles. And to find the missing sides, it would be better if you can use a by sine A equals b by sine B equals c by sine C. And when you are finding the missing angles, it would be advisable if you can use sine A by A equals sine B by B equals sine C by C. I hope you have understood today's lesson. In the next class, you will be learning cosine rule to calculate the missing sides of any triangle. Thank you and have a nice day.